Alright guys, so today we are going to start talking about what it looks like when we graph acceleration. So we've talked about distance versus time graphs already, but now we're going to talk about velocity versus time graphs. So in a velocity versus time graph, still remember the slope is still the steepness of the line, right? It's still rise over run, so the change in y over change in x. So on a velocity versus time graph, that means that it's going to be velocity over time, which we learned yesterday is equal to its acceleration. So the steepness of the line in a velocity versus time graph, the slope is equal to the acceleration. Right, so in the velocity versus time graph, Right, so velocity's here, time is down here. So V and T. Right, so now let's look at these different examples of these velocity versus time graphs. So this first one in blue, right, so the object is not moving, it has a 0 acceleration. So that means that the velocity is 0. So if you look, right, that line is down here on that 0 time and 0 velocity point. So it has to be a straight horizontal line on the bottom for it to not be moving when we're looking at a velocity versus time graph. Right, and then the next one, when we have a straight horizontal line at a particular velocity, this means that the object is moving at a constant speed, right? And so it has 0 acceleration. So this looks different from our distance versus time graphs, right? But since this is velocity, so this side over here tells us how fast it's going. So these dots mean that it is going at a constant speed of 5 meters per second throughout that time frame that we have at the bottom. Then when we've got a sloped line, right, that means that the object is speeding up, right? So if you look over here, its velocity is increasing. So it's at 0, then it's at 2 meters per second, 4 meters per second, 6 meters per second, 8, 10, 12. So it's constantly gaining speed, so it's positively accelerating. And then the other one means that it is slowing down, right? So it starts with a high velocity of 12, right, and slowly works its way down to 0. So it's coming to a stop. So this means it's going to have a negative acceleration, and then the one in orange has a positive acceleration, right, because it's going up, and this one's going down. All right, and so you can look at acceleration of objects on distance versus time graphs as well, right? So these are like the ones we looked at in class the other day. So for the first one, right, the object is not moving, right? Because in a distance versus time graph, that straight line anywhere means that it's not moving, it has a 0 acceleration. In the pink graph, right, so it's moving at a constant speed, which we learned when we talked about distance versus time graphs. But since the speed is not changing, then it has this acceleration of 0. Right, in this orange one at the bottom, we know for a distance versus time graph, that means it's speeding up, so it's going to have a positive acceleration. And then in purple, that one is slowing down, so it would have a negative acceleration. Right, so it's very important that you all make sure that you're paying attention to the labels that are on the axis, and whether you're looking at a velocity versus time graph or a distance versus time graph. The ones that will really get tricky are these, because on a distance versus time graph, that means it's going at a constant speed. But in a velocity versus time graph, when we've got that straight upward line, that means we're speeding up. So you need to make sure that you know the difference and what it looks like in a distance versus time graph and a velocity versus time graph. All right, so that's all we've got. You guys have an assignment on LMS to complete today, and please reach out and let me know if you have any questions.